So this is number 7 on the chapter 5 practice test. And we just read it and we were understanding that this rectangle, the area of that rectangle is equal to 1 whole. So let me tell you, if the whole area is 1 whole of this rectangle, if we just think about it this way, what's the area of one little rectangle? Like above, between 8 and 9. The rectangle between 8 and 9, what's the area of that particular one if the whole thing is 1 whole?
Maybe like 1/3.
Of this one? Or I know I drew these 3.
I don't know.
It'd be 1.
Wait, the one, this whole big rectangle, the pink rectangle would be the area, that area is 1. So this, just this little sliver is going to be
Oh,
what
1 out
fraction
of
of 1?
18. Yeah.
Like a point 0.1 maybe. I don't know.
Well, I drew a rectangle between each whole number, you know, between each set, and then so how many rectangles do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right?
Mhm.
So there's 10 equal little rectangles. They have the same width on the bottom and they have the same height. So there's 10 equally, I cut this 1 whole into 10 equal pieces. So what does this one have to be? What is the area of that one?
1/10.
1/10. Yeah, it has to be 1/10. Are you guys okay with that?
Yeah.
Because it's one of the 10 pieces of this whole, 1 whole.
Yeah.
That's another way of thinking about it. If you can't find the height, you know, you can find the area of 1 rectangle. And then now if we take that even further, how many, so these all are the same value. They all have the area of 1/10. So what is the area of the blue region? And let me erase it, but I just showed you that there was how many rectangles in there?
10.
4. There's 4 that fit in
Oh,
there.
1/10.
4 times 1/10, right? Or 4, 1/10 plus 1/10 plus 1/10 plus 1/10 for all 4 of them. Yeah, so you could do this problem that way, but let's
That seems easier.
right? Yeah, you could always, and you could always, you know, you draw a rectangle around everything they're telling you is 1 whole, and then you can break it up into, ideally, you between every 1 whole number, you make 1 rectangle above every 1 whole number, and then you can just count rectangles. Okay. Let's do it the way they intended. I think they wanted us to do it in a different way here. I think so. We were just focused on finding the area of this blue rectangle. So they say the base of the shaded rectangle is what? And it's usually the distance along the bottom of it.
It's 4.
It's 4. Yep. Because now we could find that in 2 different ways. You can count it 1, 2, 3, 4. Or you could have taken 15 and subtract 11, right? You could take the ending point and subtract the beginning point, and then you would have gotten 4. Either way. Okay, now the height of the rectangle.
Wait, so just ignore when it's saying to like do it in fraction form.
Oh, okay, and we have to remember to keep it in fraction form. Okay, when we do this. Okay. So what is the height of the rectangle going to be?
The height of it is going to be 1/10.
Good, good. How did you get the 10?
Because there's 10 numbers within the white rectangle.
Good, yes, yes. If you think about it, the area of this 1 rectangle has to be 1/10. We said that has to be 1/10. And if it has to be 1/10 and the base is 1, what number times 1? And I mean, to find the area of this, it has to be this height times by that base. The base is 1, the height is this. What does that height have to be if the area final area has to be 1/10, you know? So 1 times by what equals 1/10. You guys see what I'm saying? Because like the base was 1, the height of the rectangle is unknown, and the area we said, we just mentioned before that it had to be 1/10 of it because we broke this one hole into 12 equal pieces. So what does this height have to be from just looking at this equation? 1 times what equals 1/10?
110.
1/10. So that's one way to kind of bypass any algebra, and like now we know what the answer is. So that's one way to find the height, 110. But let's do the formal algebra way to do it. If you kind of even visually see that this little rectangle above one space here between 9 and 8, that little rectangle is 1/10 of the entire rectangle. And we can draw them out and see if they're equal for that too. It's kind of intuitive, but this is the formal algebra way to do it. So if you prefer, you like algebra, this would be the way to do it. We're trying to find the area of this entire rectangle. This is the area over all of the different values that are possible, all the different possible outcomes. So the area on top of these X values has to be one whole, because these are all the total possible outcomes that can take place. And we want the probability, if we add up all the possible things that could happen in a probability experiment, the probability should equal 100% or one whole, right? So the area of this rectangle has to be one whole. So in for A, I plug in 1. I give it a little hat because it doesn't look like a 1 to me. And then in for L, I plug in, I just count the base of that rectangle, the big large one. And I can either count the squares, or I could do the ending point 18 minus the beginning point 8 and get 10, the length. Now I have that the height, or whatever variable you want to call it, the height of the rectangle times by 10 is equal to 1. And whenever in algebra we have a situation where we have a number times by a variable is equal to another number, we just memorize and just fry this into our mind that we have this situation, number times variable equals another number. What do?
You times it.
Well, right now the algebra equation is saying, hey, take the height, if we knew it, times it by 10, and you're going to get 1. So we have to do the opposite operation of timesing to undo that, to unwrap it, so we can find out what the h is. So we see that we're multiplying by 10 here, so we divide by 10 on both sides, and we get h is equal to 1/10. So that's the second way that we could have gotten 1/10. Are you guys okay with that?
Yeah.
Then the last part here, it says find the area of the shaded region. So then we would know, well, we just found this height right here is 1/10. So this is the same height as this rectangle right here, 1/10. So now we have to find the height is 1/10 here, and the base was 4.
The base, does it have to be in fraction form too?
Nope. I mean, you can put it in fraction form. You can turn any whole number into a fraction by just putting a 1 underneath it. You could, but you're saying, do you think it has to be 4/1?
Yeah, because it says fraction form, so I'm not sure.
That's a good question. Yeah,
Well,
you want to just.
I put in 11 as just 11, and I got it right. So I don't think that the whole
Okay.
number. Yeah.
Okay, but you're right. That's good, Isidro, to really I'm sorry, am I saying your name right? Is it Isidro, huh?
No, it's just right.
Okay, thank you. I have to make sure. Okay, and so the area, the good. I mean, you're doing really good to make sure you have it in the right format, Isidro. Okay, so we could do 4, and actually when we multiply these fractions, it's preferable to keep it in fraction form. Maybe that's why they're asking us that, because if I do 4 times by 1/10, I can't really multiply a whole number times by a fraction, but I can if I turn this 4 into a fraction by putting it over 1. And that's fine because a fraction is indicated division saying, hey, take 4, divide by 1. And 4 divided by 1 is the same as just 4 by itself. So 4 over 1 is the same as just saying 4. So that's fine to do that. And then when you multiply fractions, you just multiply the numbers in the numerator across. So 4 times 1 is 4. And then the numbers in the denominator across, 1 times 10 is 10. And then you just get 4 tenths. But here, can we present the final answer as 4 tenths?
No.
Probably not. You're right. That's correct. I don't think we can present the final answer. What's the matter?
Has to be in decimals?
No, I think they want it in fraction form, but
And reduce it.
we can reduce it, right?
Oh,
Yeah, because 4, we see there's a number that goes into 4, right, equally with no remainder. And there's a number that divides into 10 equally with no remainder. What number is that?
2/5.
Yeah, we can divide it by 2 on top, divide it by 2 on bottom, and we get 2 out of 5. Sometimes, like if you put 4/10 into a calculator, sometimes it automatically reduces, or sometimes you can get the calculator to reduce a fraction for you. I'm not sure how to do that, but like I think you can. If you look YouTube at, you can probably get. Sometimes I notice my cell phone calculator. Sometimes I use my cell phone calculator, and when I put in a fraction, it automatically reduces the fraction. Sometimes I don't know, so I might try to use that. But anyways, I think they're going to want 2/5. And notice how there's no number that goes into both 2 and 5 with no remainder. There's 0 remainder. So 2/5 is our final answer there. Yep. And I guess we can just double check our answers to make sure I didn't any random errors there for 1/10 and 2/5. Yep. All right. Do you guys have any questions?
Yeah, if no one else has any other problems they want to go over. I got, which one?